All right, good morning, everyone. Welcome to today's CBCS seminar. Before we start, I just wanted to do an acknowledgement to country. The University of Queensland acknowledges the traditional owners and their custodianship of the land in which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country, and we recognize their valuable contributions to Australian and global society. So today we have Professor Anna Metaxas, who's going to talk to us about the IPBES Nexus assessment. For those of you who don't know what that is, you will know in a bit. Anna is a professor at Dalhousie University, but she grew up in Greece, spending every free moment as a child in the Mediterranean Sea, which is awesome. She, combining empirical and modeling approaches, she studies marine benthic populations in shallow, rocky subtidal habitats and the deep sea in temperate and tropical regions of the world. Her research applies directly to marine conservation, particularly marine protected areas, and she is heavily involved in national and international initiatives with an ultimate goal to translate scientific findings to information relevant to policy. She's also a mentor to me, and I am more than happy to introduce her to all of you guys.
Thank you. So this is my 6th time at you, and it's all because of that guy.
The loyalty.
Yeah, the loyalty. So it was very interesting, actually. In 2013, I was trying to plan where to go for sabbatical, and we'd been going to Western Australia, my partner and I, and I thought, okay, it's time to go to the east, and I didn't know where to go. Sydney was too big, Tassie was too cold, Townsville was too hot, and so anyway, we landed in Brisbane. And at the time, a very good friend of mine, Isabel Cote, was doing a sabbatical here with you, sort of loosely. And so I was at her house, and I said, I want to go. I don't know where to go. I want to go to Brisbane. She says, yeah, write to Hugh. I said, Hugh wants it out. She's not going to reply to me. I'm going to reply. It's not going to happen. Well, just write to Hugh. And I did write to Hugh, and Hugh did reply, and he was very supportive, as he always is of, bringing in more and more people. So it started in 2014, and here we are. And my next sabbatical is 6 years. Every year is about every year. Okay. So I would like to talk to you today a little bit about IPBES. I know that I think IPBES is really quite an important venue to sort of think about how science can move forward to being applied and sort of uptaken by policy. And so my role for this particular assessment was being a lead author in one of the chapters, and I'll explain a little bit how that works, which was the future Nexus interactions. And so this was on a thematic assessment that was supposed to initially look at the interlinkages among biodiversity, water, food, and health. And then somebody said, what about climate? Are we not going to look at that? And so, although it was not officially in one of the elements, we sort of added it, and it shows throughout the assessment now, but we couldn't officially change the scope of documents, so that's why you see it in brackets. So what is IPBES? So this is the name, this is the full name of it, Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. And what it is, it's an independent intergovernmental body that is established by states. It now has about 150, 160 member states. And the idea is to strengthen the science policy interface for the conservation of biodiversity and ecosystem-based the well-being, of human well-being and sustainable development. And so it has like the standard group structure, secretariat. This is the expert groups. These are panels, that observers, and then eventually a plenary, and I will get to what the role of the plenary is in a minute by the end. So what does it do? it does assessments, right? So this can be thematic assessments. For example, they did the first assessment of global biodiversity back in the 2010s. They can be methodological. So they're now doing an assessment of monitoring and how to monitor changing biodiversity and nature contributions to people. And they can be regional assessments. So they can be one for Australasia, for example. They can be one for Europe, or they can be global. And so when we think about, obviously, the biodiversity assessment, the global biodiversity assessment was a global context. So it does assessments, and that is the major role of IPBES. And then it does other things as well. So based on the assessments, it provides support for policymakers if they need certain topics addressed. They do that, build capacity and knowledge, and a lot of communications and outreach once those assessments are done, right? Sort of communicate them out. So here sits IPBES, and here sit different organizations that are involved in IPBES as stakeholders or as governments. And so you can see here, for example, indigenous and local communities. This is something that IPBES is really quite committed to, incorporating ILK, indigenous local knowledge, into all the assessments, and they have a particular unit that deals with that. You see government and non-government organizations, and then you see things like the Convention on Biological Diversity, for example, is there. And the governments sit on top. And what happens is some of these combination of these bodies here asks IPBES to do an assessment. And so it could come from the CBD, it could come from the CMS, Convention on Migratory Species. And so they ask IPBES, would like to do an assessment on this. And ultimately, governments or the states are the ones that have to approve whatever assessment comes up, the content of the assessment. Okay, so the Nexus assessment, that was sort of the one that I'll be talking about here. And so what is this? So it was sort of focusing on Nexus, what they call the Nexus approach. And basically you have those 5 different elements here: climate change, water, biodiversity, health, and food. And a lot of the previous assessments were looking at one-way interaction. So that's how does climate affect biodiversity? How does food affect biodiversity? So the Nexus was supposed to look at interlinkages among 2 or more sectors. And so you see here a list of interlinkages that we all know about. So there's interdependencies, so that if you affect one, then that may affect another one, another element, cascading impacts, compounding impacts. So all those are feedback loops, etc. So all those are the kinds of Nexus linkages that we're thinking about in this assessment. And so the assessment, the approach, as we were tasked to do, was to understand those interlinkages and those interdependencies in a holistic manner rather than taking it apart, and develop some integrating and adaptive decisions, right, to sort of maximize synergies and minimize trade-offs when we're trying to manage those crises. So the assessment had 4 main chapters. The first one was to look at the past and current Nexus interactions. The other one was to look at future interactions, response options that address Nexus interactions specifically, and then how to govern the Nexus for what they call achieving just and sustainability. And so basically, it's a massive review, just like the APCC does. And so there were 165 selected experts, and I'll be happy after the talk to tell you how that happens. The whole assessment itself is overseen by co-chairs, and there were 2 of them. Each chapter is overseen by coordinating lead authors, and then the writers, in addition to the coordinating authors, are lead authors, the review editors, and then there are fellows. And then there are contributing authors. All of you could become, any of you could become a contributing author in an ongoing assessment if you have the right connections. So again, we can talk about that. And so the Nexus assessment specifically used 6,500 sources of knowledge, and those was peer review knowledge, it was intergovernmental papers, gray literature, indigenous and local, right? So you put out a broad net and try to accumulate as much information as you can, and then we all go away and read it. And so then what I will do is
Why
I
is
give
it
you a little bit of the results from each chapter, the highlights of the results. And then also please keep in mind that the Nexus, or these assessments, they have this deck of slides that you use to sort of, talk a little bit about, what you want to present from the assessment. And so these are not necessarily my slides, they're coming from the Nexus. Okay, so first about the past and current Nexus interaction. So the first thing to look at is this group looked at indirect drivers of that could affect direct drivers that in turn will affect each one of those elements. And so here's some examples of indicators of indirect drivers: GDP, trade, population, global population size, degree of urbanization, and environmental regulations. And you can see that all of this is increasing over time. And so starting from the 1970s and getting to about 220, I guess we stopped. And then you can see that there's, of course, differences among regions of the world in terms of income. So there's differences between low income, lower middle, upper middle, and high income, et cetera. So for example, if you look at the GDP, obviously, there's low income, there's high income. And then if you look at population growth, here's low income, this is high income, and this is intermediate countries. So there's a lot of differences in terms of the actual, projections over time. So those are sort of indirect drivers that were summarized and what happens to that. And so these are now examples of indicators of the Nexus elements that the authors looked at. And again, these are changes going back to not from 1970 to present or almost present. So here are some indicators for biodiversity. So this is each one of the elements of the Nexus. Biodiversity, biodiversity intactness is decreasing. The index of species survival is decreasing. Freshwater availability is decreasing. Food supply is increasing, right? So we're sort of culturing food like crazy. So food supply in the world is increasing. And so is life expectancy, in part because food supply is becoming more widely distributed. But at the same time, we have this pesky problem here, where of course climate disasters are also increasing over time. So these are sort of the elements. So now this is now looking at the indirect drivers, so how the indirect drivers link to direct drivers. So if you look at the top here, these are direct drivers of impacting biodiversity, climate, food, etc., lands and sea use change, unsustainable exploitation, climate change, pollution, and invasive alien species. So those are some of the aspects that they could actually get from the literature. And what you see here are sort of indicators of indirect drivers. And there you see economic, demographic, institutional, cultural, and technology. And so if we look at two of the economic ones, GDP, so here's the trend, GDP is increasing. We saw that in the first figure, trade is increasing. And what this has as a consequence is sort of intensifying those direct drivers, right? So that's bad, right? So land use or sustainable exploitation obviously is going to be bad when we then think about biodiversity, and I'll link that in a minute. Similarly, when we look at demography, so population is sort of increasing and urbanization has been increasing, same thing. They're intensifying the impacts of those direct drivers. Lastly, per capita consumption, of course, we also know this is having the same effect. So these are indirect drivers impacting stuff that then will impact our elements of the Nexus. And so when we look at that, so now here's the same indirect driver. So now we're skipping from the indirect driver, based on the impact of the direct driver, how will it impact each one of the elements: biodiversity, water, food, health, and climate. And if we look at the same ones, so here, obviously, red is bad, and sort of we can see that when GDP increases, biodiversity is negatively impacted, water availability and water quality is negatively impacted, food quality is impacted, and so is health, right? The thing that is doing better is, of course, food quantity, because part of those direct drivers meant a lot more food production. And so the same with trade, follows the same pattern as it did, again, because those were all had the same effects. Those indirect drivers had the same effect on those direct drivers. Again, food quantity, because of increased trade, food is getting transported into more places, so food quantity is getting better. Population increases, the same, the impact of population increase leads to more food production, so we get more food, but everything else is not doing very well. Urbanization, same pattern, per capita consumption, same pattern. And so what we see here is sort of this, again, looking at those drivers and how they have impacted those different elements over time. But then, remember, this is Nexus that we're looking at interactions of different elements. And so what this figure showed is how the different elements now interact with one another. And so here they are again. This is the impact on those elements. And here's sort of an increase in biodiversity versus a decrease in biodiversity, increase in water, decrease in water quality, et cetera. And so if we look at biodiversity, again, this makes sense, right? But it hadn't been documented. It all makes sense. So if with the decrease in biodiversity, we'll have negative impacts on food, health, and climate change, whereas an increase will have positive impacts in all those elements. If we look at food production, if food production increases, obviously that has impacts in water consumption and in quality and negative impacts on biodiversity. But at the same, whereas if you decrease it, this biodiversity water go up, and then health goes up. Because now you're producing less food, and of course the more food leads in better dietary status around the world, and so that's the one element that will be affected if you affect food. So there's a lot of sort of interactions to think about. It's not simple, okay, we're going to increase biodiversity and therefore everything is going to be better in the world. Interestingly, this is something that we kept running into, and you'll see it over and over repeating, which is very little evidence of health. It was very, very difficult to find information or any sort of more than one-way interactions between health and any one of those elements. So that's a big gap that came up with. Okay, so that's the past, or at least up to today. And so what about the future? So the future, there were a number of studies that we looked at, and 52 of those actually had, these are scenarios, how they're going to play out, things play out in the future. And out of those 52 studies, only had 3 or more nexus elements, right? So looking at how, one element will impact the interaction of others. And based on those, we came up with 186 scenarios. 186 scenarios were presented in those studies. And for those scenarios, we created groups of types of or archetypes of scenarios to try to understand how this will play out in the future. And so here's the worst. This is business as usual. I'll start at the bottom, nature over exploitation. So those were scenarios that were showing, what happens if you have overconsumption of natural resources, unsustainable energy demand, weak environmental regulation, et cetera. And this one at the top, nature-oriented and balanced nexus, are types of archetypes that sort of deal with, they are looking at how the world will operate if we do certain things. So the nature-oriented nexus is different from the balanced one, and it has a very sort of high levels of protection. Whereas the balanced one can protection, but can restoration and sustainable use. So that is the difference between the two of them. But on principle, they both look into a number of different approaches and sort of looking at positive outcomes, things like sustainable agriculture, low consumption, et cetera. And so then in the middle there, those 3, these are archetypes or types of scenarios that sort of deal with one element at a time. Okay, so if we just do area-based conservation, right? So that's the conservation first, climate first, and we just deal with climate and we ignore everything else. And if we just deal with food scarcity, and we ignore everything else. So those are sort of the 6 of them. And here is how they play out in terms of the different elements. So again, this is positive, blue up, red is negative. The more little arrows you have, the worse it is. And so if we look at the scenarios for nature exploitation, they all predict that everything will go bad by time. It was either 2050 or 2100. It was variable. So you can see if we just carry on, things are just not going to go well. We know that. That's why Paleolithic died. But up here now we have the most balanced scenarios, and those seem to be doing, if you have approaches where you deal with every element, you manage all different elements, then all elements will benefit at the same time. If you start selecting elements first, so for example, if you just focus on conservation, that's great for biodiversity, it's great for climate, but it's not so good for food. If you just do climate, you can help health and climate, but not necessarily the other three elements if you just do food the same. So the message here is that those scenarios basically reinforce the point that we should really be thinking about a holistic approach rather than just saying, okay, we're gonna protect our little park here and then everything is going to fix itself, because all those other crises are not going to go away. And so when those scenarios were plotted against SDGs, so you can't see them here, but these are sort of all the SDGs going from 1 to 17, you can see, okay, if we start here, the bad news, red means negative, that the scenarios predicted negative outcomes in terms of these SDGs. You can see that nature of exploitation is really bad for pretty much everything. These are the two archetypes for nature-oriented and balanced, and you can see for the most part, there's a lot of blue there, so meaning that, again, there's a lot of SDGs that could be achieved based on those sort of scenarios that take into consideration all different elements. And then when we get into these ones here, again, you can see, conservation first is not very good for the ones up here, but it's good for the ones down here, which are, climate, water, below water, life below water and on land. And so you can see the same path, essentially. Now, again, interestingly, these are the ones, so zero hunger, climate action, life below water, and life on land seem to be the ones that had the most sort of benefits under archetypes 1 and 2, but also the ones that have been studied the most. Okay, so they're the ones that are most relevant. When we look at this one, clean water and sanitation and responsible consumption and production, there are scenarios that deal with them, but not as many. So here's the clean water, and so this is responsible consumption. Now, once again, we see this gap where there's no scenarios that are dealing with these 4 goals: no poverty, good health and well-being, gender equality, and partnership. So for some reason, we're not doing a very good job at trying to understand, how we address poverty, health, or gender equality with those scenarios that we're running on how the future is going to unfold. That's a gap. So that was the future. So then we looked at response options. And so these are there response options that exist that can be used to sort of address all those nexus elements at the same time? And the chapter on response options came out with 71 of them. Here they are, all listed, and they grouped them in different sort of types of responses: consume sustainable, reduce pollution, integrate planning and governance, manage risk, ensure rights, align financing, conserve systems, resource systems, and manage ecosystems. So because you can't read any of them, so for example, when we look at conserve system, some of the responses that they were able to extract from the literature were forest conservation for health, holding conversion of ecosystems with high ecological integrity. So those are the kinds of response options that they have. And it's not that a particular response option will be applied to everything, but the idea is that there is enough there that we can draw from to be able to address a combination of the different elements. And here's some examples where they actually plotted whether those response options, which elements of the nexus they would impact, and the size of the circle suggests how much of an impact that response has on a particular element. So these are ones that are for conserving ecosystems, and so area-based conservation, the larger the circle, the more the impact they'll have. Obviously, area-based conservation has a lot to do with impact biodiversity. a little bit for climate, less so for food or water. Okay, so that's one example. Conservation, forest conservation for health seems to be doing a lot better. It has pretty large circles for all elements except for food, because of course you have to give up land for food to have forest conservation. Rewilding, again, it does pretty well for biodiversity, water and climate. Not so good for food, again, because every time we rewild, we give up land that could be used for agriculture. Someone here, this is integrating planning and governance, right? So if we think about integrated landscape and seascape approaches, that is something that can be used for across the nexus. It has quite positive impacts on all elements. If we do that, that's a good thing. Groundwater governance, etc. So basically, the idea here is that we have all those options, and each one of them can have benefits for all elements or most elements, and we should be considering all those elements when we're considering our response options. And then what this chapter's authors did is they tried to map those response options under different conservation frameworks that exist. These are SDGs, Global Biodiversity Framework, and Paris Agreement. And so there what you see is in the number of brackets here, this is each one of those categories and the response options. And in the number in brackets, you see how many individual options were listed under that particular category. But the idea here is that, for example, if we're reducing pollution, those 7 response options could actually address 8 SDGs, right? If we look at all of them, we could probably address 8 SDGs, 10 of the 23 targets of the GBF, and both climate targets. And so, again, there's a lot of options, and the smallest number that you see here is like 7 for SDGs, and it's 9 for GBF, and 2 both for climate. And so, again, let's look at our options and let's see, because some of them can actually address quite a few of our sustainability goals if we just look at more holistically, rather than just focus on a few, on one particular approach. And so the whole thing sort of has to come out with some grandiose statement. And so this is what the combination of the roadmap of Nexus action is. And so what happens here is we start with the current state, and we end up with some just and sustainable future, which is what the hope is. And we see 3 sort of groups of steps along the way. So the one is exploration of the Nexus context, coordination of strategic action, and implementation and scaling. And so for exploration, this is the stuff we're talking about, looking at direct and indirect drivers, figuring out who the actors are that will sort of be able to deal with those drivers, to manage those drivers, and understanding those Nexus elements and interactions. So that's the first step, basically figuring out what we have, what is happening. The next one is, once you have those, you sort of think about co-creating visions. Again, that's very important for IPBES, right? Having different actors, different value systems, and sort of getting together and creating this future, this values that it comes from all the actors involved, and then identifying response options that would be useful for whatever the actions are that you want to take. And the last one, of course, is implementation and scaling. So assessing the enable conditions and what the barriers are, negotiating implementation, and then, of course, monitor, etc. Now, for each one of those steps, you can see with this black arrow sort of indicate you go from step to step, so direct and indirect drivers, actors, etc. And so does the black arrows. But then the idea is that you also have these guardrails with the safeguards where if you get to a point and then all of a sudden, this is not going the way you think it was going to go, like it's not going towards a just future, then it stops and then it reverts back and sort of you reassess, right? So the adaptive management planning, or whatever you want to call it. And so that happens all along the way. And so sort of the conclusions of that assessment was that obviously, urgent action is needed. We know that to tackle the crisis. That the assessment, and that's what assessments do, is they provide the best available evidence to decision makers, and in this instance was the interlinkages about biodiversity, water, food, health, and climate change. That there is a wide range of response options that are available and that will be addressing multiple elements of the nexus. And so we need to sort of start looking at those. There's also evidence and tools that exist about those interlinkages and how to make decisions that are integrated and take action that is integrating. I didn't talk about this because it's not really my forte, but there was also an entire aspect of economic and finance and governance systems that can actually help evolve towards that holistic approach. And importantly, there's different actors that have different roles, and they all need to be engaged in this if we're going to solve this problem and sort of, make more integrated decisions. So, bottom line, right? We have this crisis, they're interlinked right now, we're not responding to them in a way that is holistic. We have solutions, everybody has their own plan. So, okay, so all of us work in conservation, we all know that, big surprise, right? We all know this, well, not so fast. So, what happens then is this assessment with those conclusions that are pretty obvious has to get out there, has to be publicized, has to get approved. And so this is where the science ends and the politics start, okay? So what happens is this assessment has to go to plenary, presented, and then all the states have to approve it before it becomes public. The Nexus assessment was probably the most controversial assessment ever. There were tears, there was just did not go very well. You'd think it's obvious it should. Parties or states wanted to argue the content, the scientific content. They got the chair of the actual plenary said you can't argue the science, but what they did argue is what is included in the summary for policymakers and how it's presented. So just some examples, countries that, for example, South America, they want to produce food and cut down the forest. They don't want to hear that, that food production, dealing with the food crisis alone is going to bring a catastrophe for everything else. So that's not necessarily, it's argued, it has to be argued to keep it in. And so there's a lot of politics that happens at this stage. Anyway, it did pass plenary eventually, after a lot of arguing. Interestingly, at the same time, there was another one called Transformative Change, which was also an assessment that was going through. And this was all about changing how we deal with the world, like transforming the way we do our business completely, actors and how we engage actors, etc. And that sailed through because there were no contentious issues like growing beef or, cutting down the forests. So it was easier to get that. Okay, so it gets to plenary. Now, the IPBES, the Nexus assessment was requested by the Convention on Biological Diversity, right? Sitting right here. They said, we would like you to do a Nexus assessment, of an assessment of those interlinkages. So then it has to go to the Convention on Biological Diversity to get accepted, received, right? Not approved, just received. And so that was showed up in the scientific body of the Convention on Biological Diversity in Panama in fall 2025, and it would get through. So right, there's certain states like Russia, like Brazil, South America, that just don't want to receive it, which is bizarre, right? You ask for it, now you don't want it. And so basically we have a situation where we have the work of 165 people who have read the entire body of literature, they have come up with all this, they present the results to the report to the body who asked for it, and the body says, we don't want it. Don't like what it said, whatever, for whatever reason, we don't want it. So it becomes sort of very political, right? And so that's, as with all these things, as with the IPCC, et cetera, it's the same deal. At the end of the day, it becomes really quite political. Even if the people that don't receive it are the people that requested it, that don't like what the science was about. So that's it in a nutshell. Here is the actual link for if you want the summary for policymakers. You can download it and get more information. I'll stop here and I'll take any comments or questions.
Thanks, Anna. For those